Hello, welcome to my channel. In this video, I'm gonna solve another exercise problem from chapter 3, practice exercise problem 3.6. We have to determine divergence of the following vector fields at specific field points. So the vector fields are A, yz in the direction ax, 4xy in the direction ay, plus y in the direction az at point 1 minus 2 3. This is in Cartesian coordinates. The second vector field is B, which is in cylindrical coordinates rho z sine phi a rho plus 3 rho z square cos phi a phi. At we have to find the divergence of this vector field in cylindrical coordinate at uh, point 5 pi by 2 1, and the last vector field is in the spherical coordinate system, which is 2r cos theta cos phi in the direction ar, plus root over r a phi in the direction a phi at spherical coordinates 1 pi by 6 pi by 3. Now let's get started with the problem solving, but before we go to the problem solving part, we have to understand what divergence is. So here, divergence of a vector is, so given a vector field A, divergence of that vector field A at any point P is the outward flux per unit volume as the volume shrinks about P. So divergence is expressed in mathematical terms by div of divergence of the vector A, which is del operator acting on the vector, and by definition it can be expressed like this, where limit of so the volume is going towards zero as the uh, outward flow of the vector field through the surface S is measured. So this is the full definition of divergence of a vector. Now we are gonna see how a vector how a divergence looks, how a divergence of a vector looks. So these are the three cases of uh, divergence in general we see in vector fields. So this is the positive divergence, or this is the main divergence in, as we have defined, the outward flow of flux per unit volume um, about P, about point P. So the flux is going outwards from the point. This is the main actual divergence, and also this is the positive divergence if the flux is towards the point um, as volume shrinks down. It's a negative divergence, or it is called convergence. This is convergence. So this is called convergence, and there is no divergence or convergence about P. So this is zero divergence. So these are the instances of divergence graphically. So divergence, in a nutshell, divergence means outward flow per unit volume from a point, and divergence of a vector, and divergence of a vector is a scalar, and divergence is used to determine if a vector is conservative or not. Divergence means limit of a field source strength per unit volume. This is the gist of divergence of a vector. like this is the summary of a divergence of a vector. If we want to calculate divergence of a vector field, we are gonna use this. So we are taking divergence of a vector. So if the vector field is in Cartesian coordinate system, the answer is del by del x ax plus, so a is a vector, so it will have components in the specific directions, dy ay plus del by del z az. So this is a scalar, there's no unit vectors associated with the components, and the partial differentiation of the components um, in specific directions without the direction. So this is the um, answer for Cartesian coordinate in cylindrical, 1 by rho partial differentiation with respect to rho a rho plus 1 by rho partial differentiation with respect to phi a phi component, and del partial differentiation with respect to z, the component is z, and in spherical r square partial differentiation with respect to r squared, the component ar, the spherical component ar, 1 by r sine theta partial differentiation with respect to theta a theta sine theta plus 1 by r sine theta del by del phi a phi. Now let's get to the problem solving part. So this is our first vector, and the corresponding components in the direction ax, ay, az are ax is yz, ay is 4xy, and az is y. So we take the divergence of this vector, so which is del by del x ax plus partial differentiation with respect to y ay plus partial differentiation az will give us, so yz plus del by del y for xy plus del by del zy. So here 0 plus there is no x component, there is y component, so 4x plus 0, thus 4x. So divergence of a at 1 minus 2 3 is 4. Now the second vector field is this, and we have to take the divergence of it in the cylindrical coordinate system. So partial differentiation with respect to rho b rho plus 1 by rho partial differentiation with respect to phi b phi, and bz is 0, so there is no partial differentiation with respect to z. So now 1 by rho del rho, so rho square z sine phi plus 1 by rho del by del phi 3 rho z square cos phi. So if we take the partial differentiation, which will be 2 rho z sin phi, rho cut out, plus 1 by rho. So partial differentiation of cos phi is 3 rho z square minus sin phi, which is 2z sin phi plus 3z minus 3z square sin phi. So we add 5 pi by 2 1 is, so 2 cross 1 sin pi by 2 minus 3 cross 1 square dot sin pi by 2, which is, this is 2 minus vector field B in cylindrical coordinate system is this, and divergence of which is 2z sin phi minus 3z square sin phi, and at the point 5 pi by 2 1, the magnitude of the divergence is -1, and this is the answer. So this is the vector C in spherical coordinate systems and its corresponding components in the direction. Now we have to take the divergence. So divergence of C, the vector field C, so which is in spherical coordinate system, then the formula would be, so theta, C theta component is 0, so this part vanishes. So 1 by r del by del r, so 2r cube cos theta cos phi plus 0 plus 1 by r sin theta del by del phi root r, and that's it. So 1 by r, so partial differentiation with respect to r is 6r square cos theta. So here there's no phi component, thus it's 0. Now divergence at 1 pi by 6 pi by 3, which is, so this cuts out here, so 6 dot 1 dot cos theta, so cos pi by 6 cos pi by 3, which is 6 dot 3 by 2 dot half is 3, so 3 root 3 by 2. Vector field in spherical coordinate systems is this, and its divergence is the scalar this 6r cos theta cos phi, and at the point 1 pi by 6 pi by 3, the value is 3 root 3 by 2, and this is the answer. This is for this video. That's it. Thank you for watching this far. I hope you understood my explanations and the calculations, and thank you.